Hello everyone. Today we shall discuss a project titled Prediction of Term Deposit. We will be exploring different features in the dataset, their pre-processing steps, and also we will be conducting exploratory data analysis of both univariate and multivariate data. Additionally, we will discuss methods for reducing dimensionality in the dataset and then proceed to the exploration of application of diverse classification and clustering algorithms along with the results. So to give you a background of the term deposit, a term deposit is a fixed term investment that includes the deposit of money into a financial institution like a bank, and the money invested can be withdrawn only when the term ends, or otherwise, usually a penalty is charged. So let us have a look at the problem statement. So the data that we've considered is related with the direct marketing campaign of a European bank. The data is based on the phone calls that were made during the marketing campaign. The classification goal is to predict if the client would subscribe to the term deposit or not based on the previous marketing data. So let us move on to the feature description. So age, which represents the age of the person, job type, which represents different categorical variables like administrative jobs, unemployed, management, housemaid, etc. Marital, which includes categorical variables like married, divorced, and single. Education, which includes four categories: primary, secondary, tertiary, and unknown. Default, it states whether the person has ever defaulted in his credit history, and it's a binary variable with yes or no. Balance, which depicts the average yearly balance in euros. Housing, it states whether the person has a housing loan or not. Loan, it is the same as housing loan. It says whether the person has a personal loan or not. Contact, it is the communication type that was made during the campaign. It includes three categorical variables: cellular, telephone, and unknown. Day, which is the last contact day of the month. Month, which is the last contact month of the year, and it is a categorical variable which includes values from Jan to December. Duration, it is the number of seconds that the person has talked on the phone. Campaign, it is the number of contacts performed during the current campaign for a particular client. P days, which is the number of days passed after the client was contacted from a previous campaign. Previous, which is the number of contacts performed in the previous campaign for a particular client. P outcome, it is the outcome of the previous marketing campaign that was held earlier. Y, which is the target variable, it tells whether the particular person had subscribed to the term deposit or not. The total observations in the dataset are 45,211, and there are 17 columns. Let us have a look at the overview of the data. It represents the first five rows of the data. Here we can see different features of the dataset and its and the five rows of it. Balance includes negative values as well, which means that few clients have outstanding debt. P days minus one, which means that the client was not contacted in the previous campaign. Now let us have a look at the summary of the data. So as you can see, the minimum value for age is 18, and usually the banks would allow to deposit money only when they're 18 and above, and the max age is 95. Minimum balance is minus 8019, which means that they have outstanding debt, and the maximum value is 102,000 euros. And similarly, the minimum duration is 0 seconds, and the maximum duration is 4,918 seconds. In this box plot analysis, we can see that most of the numerical data shows outliers except for the day feature. These outliers are considered valid as they represent genuine data points. For example, as we see the age feature, in age outliers might appear, but this aligns with the reality that people can have ages that may seem unusual in the dataset. That is why we are not removing any of the outliers. Moving on, this is the dataset with respect to the subscribed, which is the target variable in our dataset. We can see that there is a massive imbalance in the dataset. Around 40,000 people have said no, have not subscribed to the term deposit, and only around 5,000 have subscribed to the term deposit. So in order to handle this imbalance, and also we have also performed one-hot encoding and label encoding to the data prior to oversampling or upsampling. Here, as you can see, after oversampling using SMOTI method, we can see that resampled observations have increased to 79,844 from 45,000. This is the covariance matrix. We observe some interesting relationships, particularly considered with subscribed data, which is our target variable. So several attributes displayed significant covariance values, but duration demonstrated a noteworthy positive covariance, which implied a relatively strong positive correlation with subscribed data. This suggests that longer duration of contact might have a positive influence on the likelihood of subscription. PDAS and previous also exhibited positive covariances, indicating a potential connection between the likelihood of subscription. Also, attributes like features like month, housing yes, contact unknown, and P outcome unknown have shown relatively negative covariances with subscribed data. This tells that the negative relationship with months having a house loan and contact unknown methods of previous outcomes might have a lower likelihood of leading to a subscription. So moving on, this is the correlation matrix that reveals the correlation values between different variables in our dataset. With respect to subscribed, which is our target variable, we see a positive correlation with a duration of 0.45, indicating that duration of contact during marketing campaign may positively influence the likelihood of a subscription. Additionally, there's a mild positive correlation between subscribed and P outcome success, which is the previous outcome. It suggests that the successful previous outcomes could slightly contribute to increased probability of subscription. And also subscribed, it has negative correlation with variables like housing yes of minus 0.40 and also minus 0.37 with contact unknown, which tells that having a housing loan or unknown contact methods may negatively impact the likelihood of subscription. Moving on. So we have performed PCI analysis for as part of dimensionality reduction. So dimensionality reduction, it allows us to understand the most impactful features in our dataset. So let us have a look at the values or the results that we've obtained. Firstly, the condition number. So the original dataset exhibited a condition number of 178, around 178. And after reducing the dimensions, we can see that condition number significantly reduced to 7.57. This implies a notable reduction in multicollinearity, making the reduced dataset more error-proof. Moving on to the singular values, which indicate the spread of variance across the components. The original dataset required 20 components to explain 95% of the variance, while the reduced dataset achieved the same explanation with just 6 components. So this reduction from 20 to 6 components signifies that we have effectively captured the important features in our dataset. Moving on. Here, we have also performed variance inflation factor analysis to identify the multicollinearity among the features in our dataset. So a VAF value greater than 5 indicates a high degree of multicollinearity. So we in our dataset we have P outcome unknown, which has a VAF value of 8.62. It indicates significant level of collinearity with other variables. Also, day and month have values around 5, which is 4.33 and 4.21. Moving on, we have also performed random forest analysis. We have derived a list of features and along with their importances. And for each feature, we are predicting the target variable. So duration stands out as the most influential feature with an importance score of 0.36. And following that, contact unknown, housing yes, balance month also follow as important features, but to less extent than duration. It set a threshold of 0.06, and we were able to eliminate most of the features. And we selected four features: balance, duration, housing yes, and contact unknown. And we've used these features for all the analysis that we have done for all the classifiers in the clusters. Moving on. So we have also performed OLS stepwise regression, and for this we have selected age as our target variable, mainly because since our target is a categorical variable and we cannot perform linear regression on a categorical variable, so we have considered age despite being a discrete variable. And these are the features that got eliminated, and as you can see, the p-values are higher. And on the right hand side, we have the regression equation that is formed after performing the OLS summary. Moving on. So the features obtained from the OLS summary, we have done the t-test and f-test analysis on it. So for the t-test, we have two values here. The first value, it represents the magnitude of the difference between the observed value and the hypothesized value. The second value, it is the p-value, which tells about the probability of observing extreme value of the test statistic. Also on the right hand side, we have the F statistic, which examines the overall significance of our model. So this value is 0.00. Since this is substantially less than our chosen alpha, which is 0.05, we reject the null hypothesis and conclude that our model is statistically significant. Moving on, we have generated a line plot that compares the actual test data against the predicted values obtained from our model. So upon observing the plot, we notice that there is a difference between actual and predicted values. Actual values span a range of 20 to 95, but the predicted values, they are specifically between 35 and 60. So this discrepancy between actual and predicted ranges suggests room for improvement. It is evident that our model isn't precisely capturing the entire variability present in the target variable. Now let us explore the features by selecting the features from OLS model. Here also we see a similar trend as with random forest model, but the actual values have a little wider range, varying between 20 and 95. Uh, but it spans around 29 to 65, and the discrepancy between actual and predicted states that our model captures a broader spectrum than the random forest model, but there's still a notable gap between the ranges. Now let's compare the two different models based on the evaluation metrics. So R squared, our model explains 3% of the variance in the target variable, which implies that the predictors captured by the model explain only a small portion of the variability. Adjusted R squared, which is similar to R squared, it stands at 3% for random forest. And for stepwise regression, it stands at 22%, which is significantly better than the random forest model. Also, AIC, BIC values have improved compared to the random forest model, indicating better model performance. Also, if you can see, MSE is better for uh, linear regression OLS model. Now, let us discuss the prediction interval that is for the predicted age along with its 95% confidence interval. And this is based on stepwise regression model. So we can see that the predicted ages are approximately between 29 to 65, and the confidence interval spans around 25, extending to 75. Still, we can see a discrepancy between the actual and predicted. Uh, so this wider confidence interval also, it tells that our model is still it needs to be improved. And let us now move on to the third phase, exploring the classifiers. So this is the decision tree classifier for pre-pruned data. This decision tree classifier was optimized using GridSearch CV to enhance its performance. So after tuning various parameters, the best model achieved was with an accuracy of 84% for on training data and 83% on the test data. The best parameters, as you can see on the right, and the area under curve for the ROC curve is 0.90 for this. This optimized decision tree classifier had a robust performance with balance, precision, and recall. It made it a reliable model for the given task. Now, heading on to the post-pruning. To improve the efficiency in the decision tree classifier, we perform post-pruning by downsampling the data, resulting in the reduced training dataset as it was taking a lot of time. So the best alpha we could find was 0.00031, and the model achieved an accuracy of 87% on the training data and 83% on the test data. The prune model also exhibited a balanced precision of 81% and recall of 87%, and the AUC for the ROC curve is 0.90. Now moving on to the logistic regression, the model was trained and tested on pre-processed data. After extensive hyperparameter search, the best configuration was found to be the C-value was 1 and L1 penalty using the Saga solver. The precision was 81% and recall was 86%. Additionally, it exhibited both 80%, 83% on both test and train data. Now, exploring the k-nearest neighbors classifier, multiple k values were evaluated to determine the optimal performance. The error rate versus k values plot, it showed a decreased trend after reaching around k equal to 15. And using a grid search CV for hyperparameter tuning, we were able to emerge the optimal choice of k as 14. With a train accuracy of 86% and test accuracy of 80%, 84%, the KNN model exhibited a robustness in generalizing the unseen data. Also, it had the AUC area under curve of 0.91. Now, moving on to support vector machine. So, we employed various kernel functions for classification, but due to computational limitations, we focused on linear SVM only. So as you can see, the train accuracy and test accuracy is both 80%. While this model gave a balanced performance, but the precision and recall were very less, and the specificity was 67% with an F1 score of 82%, and the area under curve was 89%. Linear SVM was overall was an average performance, but since we did not perform any other kernel functions like polynomial and radial basis, this was kind of better. Now moving on to the naive Bayes, it demonstrated train accuracy of 78% and test accuracy of 77%. The model strength is basically lies in its simplicity and efficiency. It excelled in identifying positive cases since it had greater F1 score of 80%, and it had AUC of around 87%. Now moving on, random forest using bagging classifier. So this is an ensemble method, and we have performed hyperparameter tuning for this. We saw that it had a number of estimators of 100, and the results showed 85% on test accuracy and 95% on train accuracy, and it had a precision of 82% and a commendable recall of 89%. The specificity was around 80%, and it showcased a balanced performance across different evaluation metrics. Also, the AUC score was 92%, which emphasizes the model's effectiveness in distinguishing between classes. Moving on, the stacking classifier. The model was optimized using grid search CV, and we have the best parameters displayed on the right-hand side. It gave an high accuracy of 90%, showcasing its ability to learn and generalize well. And on the test perspective, it gave an accuracy of 85%. Also, the AUC score for this was 92%. Moving on to the boosting. So we used AdaBoost classifier, which is an ensemble method for employing random forest as a base estimator. It had scored an accuracy of 94% on train accuracy and 85% on test accuracy. Analyzing the confusion matrix, the AdaBoost shows a precision rate of 82% and also recall of 88%. The AUC score was again 92% for this particular classifier. Now moving on to multi-layer perceptron. Uh, this is a powerful neural network based algorithm. So we employed predictive multiple layers of interconnected neurons, and we also performed grid search for this particular classifier. And we found that ReLU activation function and alpha value of 0.0001 was found for the best classifier. It demonstrated an accuracy of 84% on the training, and on the test, it had 83%. The AC score was around 90%, which is really good. So overall, these are all the accuracies, different metrics for evaluating or comparing the models. So in our rigorous evaluation, we found that stacking classifier outperformed all the classifiers. It excelled in precision, recall, specificity, and achieved an AUC score of 0.92. With the precision of 82% and recall of 89%, it was when compared to others, it was the best we could get. And now we will move on to the clustering methods. Clustering algorithms like k-means, it requires identifying optimal number of clusters, which is k. So we have performed silhouette method and also elbow method, and we found that the optimal k value was to be 3. So moving on. So we have also performed a priori algorithm on few of our categorical variables. So we identified the most common item sets with the corresponding support values. We found that 50% of the transactions involved the subscribe category, and approximately 46% categorized as marital, and about 38% were housing yes. Moving on to the association rules table, the rules demonstrated the relationship between different categories based on support, confidence, and lift metrics. The rule loan yes to marital marriage shows that around 6% of the customers with loans are married, exhibiting a confidence of 62% and a lift of 1.35. Additionally, we also see significant features associations between features like housing yes to marital single, which indicates that around 25% of the customers with housing loan are single. So all in all, in this project, we employed various classifiers and ensemble techniques, and we explored different classifiers as well. But the stacking classifier stands out as a top performer, showcasing its superior precision, recall, and AUC score of 0.92. This analysis revealed also the K-means analysis revealed three distinct clusters within the feature space. And to enhance the classification performance further, fine-tuning hyperparameters, exploring advanced ensemble techniques could be beneficial. And additionally, the insights from association rules and feature importances analysis provided us with valuable strategic insights for business decisions. Thank you.